Hello, little Falkenstein children. It is your Uncle Jim again. It's been a long time, but lucky for you, the wait is over. Another page in the intellectual devotional. Oh, dreams do come true, don't they, kids? All right. So today's story is called Surface Tension and Hydrogen Bonding. Oh, this is going to have a lot of tension and a little bit of bonding. Both those things are good for families. Oh, wait a minute. Let's wait for that helicopter to go by. Can you feel the tension building? Excitement for the story? All right, let's see if that's surface tension. Maybe it is. Water is the strangest, most ubiquitous substance on Earth. Ubiquitous, that means it's all over the place. Some of it's inside your mouth. Some of it's in the toilet. That means it's everywhere. Its solid form is less dense than its liquid form, which is why ice floats. It can absorb large amounts of heat without changing very much, which is why coastal towns have moderate temperatures. That means that's why it's warm and sunny here in Los Angeles, and I'm not wearing a jacket, and it's January. And it has a skin, a thin layer of molecules that try to stick together at the surface. Water has skin on it. Every time you drink a glass of water, you're drinking its skin first. Skin, water skin. Wow. It's like you're eating a water animal. That makes water more cool, doesn't it? Water's unusual properties are the result of its shape. A water molecule consists of 2 hydrogen atoms and 1 oxygen atom, H2O. It looks like Mickey Mouse. Hey, water has skin on it, looks like Mickey Mouse. Maybe water is really a mouse. Let's see. The 2 hydrogen atoms are the ears, and the oxygen atom is the head. Because electrons aren't distributed evenly in the water molecule, the ears are positively charged and the head is negatively charged. Since opposites attract, the ears of one water molecule are attracted to the chin of another water molecule, forming a hydrogen bond. They have not mentioned the tail of the mouse yet. And the chin of the mouse is apparently more important than the nose. Maybe there's more to this water business than you and I know. Where did we go? In ice, water molecules bond together stably to form a tetrahedron, a 4-sided pyramid. Let me tell you something. Pyramids have 3 sides. This book might not be on the ball. Maybe you and I are smarter than this book. Remember that for your whole life. You're always smarter than a book. But in liquid, the structure of water molecules is looser. Hydrogen bonds are constantly breaking up and getting back together. Man, you know, there's a couple on the street that's kind of like that. They break up and get back together a lot. It's kind of like a soap opera. So that means that water molecules are like a soap opera, and that ice is like a mouse, and that regular water has skin. And we're learning a lot. In fact, the average hydrogen bond lasts only a fraction of a second. In the middle of a glass of water, any given molecule is being pulled equally in all directions, so there is no net effect. But at the surface, there is no force to pull the water molecules up. Molecules are pulled more to the side and down, which is what creates water's sticky skin, or surface tension. The skin is sticky. Water skin is sticky. And somehow strings pull water down into your glass. There's probably got string in your water too. There's string and sticky skin and mice in your water. And if you have ice in there, then there's a soap opera in your glass of water. This is great. Let's see, where did we go? Surface tension allows us to fill a glass above the brim. It makes water bead up and form drops and allows it to be stretched into bubbles. Oh, bubbles. That's why you can make bubbles, because of the surface tension. The bubbles probably have skin inside them, but no mice in them. Alright, additional facts. Water striders, light insects with pad-like feet, take advantage of water surface tension. They literally walk on water. What else walks on water? Jesus. So Jesus probably was about the size of a little insect and had really wide feet. Right here in the book. Water's surface tension is strong enough to drown flying insects that accidentally fall into it. They can't flap their wings fast enough to escape the pull of the water molecule. So little bugs think that water is kind of like quicksand, because probably the skin and probably the mice that are inside water will eat the insects. That makes sense, really. Detergents work by lowering surface tension, which allows water to more effectively soak into pores and dirt. Boring. I don't know what detergents have to do with mice and insects and skin on the water. So, surface tension and hydrogen bonding. There you go. That is this week's intellectual devotional. Oh, that's the back. There's the front. It's your Uncle Jim saying, see you next time. Woo!